Hello, my name is Peter Szczepanski, and in this video we'll be going over assignment 14, also known as the ellipse class, and then computing over the ellipse. Okay, so why don't we just run this file, and then I'll explain what is going on. Alright, so we can do that through main, and what it's going to do is it's going to go put us through two tests, so one simple ellipse, which is essentially like a circle, and then a more complicated ellipse. I'll show how that looks after the test is done. Because I'm using like a pseudo number random number generator for it might take like a longer time to do this because I'm generating over a lot. Okay, so for circle A, which is the easy problem, as you can see here, the radius is 1 at 0, 0, and then 1 over 0. The overlap was 1.2279. And then when it came to like the ellipse, where it was like a little bit more complicated, where the foci were located at negative 1.5, 0, 0, 1.2, and then 0.7, negative 0.4, and then 1.6 and 0.9, with widths of 2.8 and 2.4, the overlap was approximately 0.49096. Okay, to show you how that looks like, here are my two quote-unquote ellipses that I created. This one's obviously like more of a circle, but the circle does qualify as like an ellipse. And then here's like the more complicated one, where it's rotated a little offset of an ellipse. And then what I did was I used the War and Peace pseudo number generator from earlier, and then I made it go through and rotate it through 160,000 times, which is essentially like that many points on the thing. Okay, so then we did that, and then now we're gonna explain my ellipse class. So if we scroll up to the ellipse class, um, as you can see here, it takes two foci, and then the long axis width, which is 2a. A point inside the ellipse if the sum of distances of the two foci is less than or equal to the width. So then essentially what it does is initializes it right with the two foci and then the width, and then it finds like the center of it, then the distance between the two foci, and then essentially gets like the computes A and B from A and C, which is like the Pythagorean theorem essentially, and then essentially it gets like the long distance width after it gets contains, and then the main accept reject function is the compute overlap of the ellipse. So as you can see here, I kind of use the War and Peace number generator to help with this. I made a uniform box around that covers both ellipses, and it helps to reduce the variance. And I used a stratified grid with one number jittered sample per cell, and then it helped me to calculate the accept rejection weight. All right, thank you.